Gene cloning tools pUC8 as a plasmid vector. So let us look at the learning outcomes of this session. pUC8 is a descendant of PBR322. This was one of the first plasmid vectors that was constructed, and the pUC8 retains the origin of replication and ampicillin resistant gene of PBR322. pUC8 has a lag Z prime gene as a selectable marker, and within the lag Z prime is present a multiple cloning site. pUC8 has a high copy number, is small in size, and selection of recombinants can be carried out in a single step. This prospect is a very attractive prospect. Several modifications of pUC8 has led to a different set of plasmids with improved specifications. So let us look at the construct of the pUC8. As you can see, pUC8 has a very small size, about 2750 base pair, which indicates that one can add an insert or a gene of insert of anywhere between 7 to 8 kb. So when you have 7 to 8 kb of gene inserted into the pUC8, it still is around 10 kb. And we all know that a size of 10 kb is easy to handle, it is easy to purify. Therefore, this prospect that it is just 2750 base pair is a very important specification of pUC8. The second observation is that, or the second characteristic that pUC8 has, is that it has the ampicillin resistant gene, and which can act as a selectable marker, and it also has the lag Z prime gene, which is a second selectable marker. It of course has the origin of replication, and within the lag Z prime it has a cluster of restriction sites. So in all, one can see that it is fulfilling all the characteristics that a cloning vector should have. Now what is interesting to note is this, that the AMP resistant gene, which in PBR322 had several restriction sites, in the pUC8 it has been modified such that the ampicillin resistant gene portion does not contain even a single restriction site. So therefore, the ampicillin resistant gene can never be disrupted, and hence the ampicillin resistant gene will never be inactive when pUC8 is transformed into E. coli. So therefore, the ampicillin resistant gene is a sure shot gene for selecting the transformants. So if you have pUC8 getting transformed into E. coli, then all E. coli containing the pUC8 will grow in a media containing ampicillin. So that is what is called as a positive selection for transformation. Now, the media with AMP is therefore significant enough to ensure that one can come to know whether an E. coli has taken up pUC8 or it has not taken up pUC8. Those E. coli that have not taken up pUC8 will not grow in the media with ampicillin. Now, the origin of replication too has been modified, although this origin of replication has been retained from PBR322. It has been modified, and these modifications have led to a higher yield of the plasmid. So you get a higher copy number of plasmid. What is observed is that 500 to 700 copies per cell is made. So one can easily imagine that the amplification of the gene of interest within the pUC8 can be much more than what is observed in PBR322. So this is again an interesting facet of pUC8. Now, the lag Z prime, which is also a selectable marker, it actually codes for only the alpha peptide part of beta galactosidase. And we all know that beta galactosidase is a part of the lag operon and is responsible for utilization of lactose. So we will eventually look at how lag Z prime is an efficient selectable marker. Now, within the lag Z prime region, that is within this gene, which is a secondary, which is a selectable marker, one has or one contains a polylinker, and this polylinker has every linker in the polylinker having restriction sites. So you have a restriction site for HIN3, PST1, SAL1, BAMH1, SMA1, EcoR1, and so on and so forth. So therefore, when you have multiple restriction sites, then this is what is called as the multiple cloning sites. So within the lag Z prime, you have a cluster of restriction sites, and it is also called as the multiple cloning site. Now, therefore, suppose you have or you insert the gene of interest by using any of this restriction endonuclease, then the gene of interest will lie within the lag Z prime and disrupt the lag Z prime. And therefore, that leads to what is understood as insertional inactivation, and hence it can be used as a selectable marker. For what? For recombinants. So AMP-R tells us that the E. coli has got transformed, but the lag C prime tells us that the E. coli has the recombinant. So this is essentially a very good characteristic of the pUC 8. And the selectable marker for recombinants is observed in a media that contains X-gal. X-gal is a substrate for the lag Z prime per se. Now let us look at more about the lag Z prime. So, what has been observed that there are certain mutants of E. coli, Laxat delta M15, that have a defective beta galactosidase. Now, because this mutant has a defective beta galactosidase, it will not be able to utilize lactose and convert it to glucose and galactose. Now, suppose this mutant E. coli is supplemented with lag Z prime. So if lag Z prime is present, and we all know that lag Z prime is the alpha component of the beta galactosidase, so it is about 146, it gives rise to a product which is about 146 amino acids, and that 146 amino acid is the alpha peptide of the beta galactosidase. So the lag Z prime actually makes the defective beta galactosidase effective. And because of that, what will happen is lactose will get converted to glucose and galactose. So this phenomenon is what is called as alpha complementation. So the laxi prime provides the alpha peptide to the defective beta galactosidase to make it a complete beta galactosidase, and now this mutant will start using lactose and converting it to glucose and galactose. This is also considered or known as a phenomenon of what is called as marker rescue. What does this mean? It means that a defective beta galactosidase, by having taken up lag Z prime, becomes a complete beta galactosidase. So a marker can be rescued. If you do not have lag Z prime, it cannot be used. But if it has lag Z prime, then it can be used. Now pUC8 has lag Z prime. So when this mutant E. coli takes up pUC8, obviously you would have alpha complementation and lactose will get converted to glucose and galactose. Now if you were to use therefore this strategy for selection, then one cannot use lactose because you will not be able to visually observe that lactose has been converted to glucose and galactose. So what has been done is that a chromogenic substrate X-gal, okay, is used in the selectable media, and this X-gal can be acted on by beta galactosidase. So X-gal is actually broken down into 5-bromo-4-chloroindoxyl by beta galactosidase, and this in turn dimerizes to form 5,5' dibromo 4,4' dichloro indigo, which means that the product that is formed because of X-gal being converted by beta galactosidase is blue in color. So the formation of a blue color indicates that the beta galactosidase is active. Now, interestingly, the lag Z prime is induced to be expressed by IPTG. IPTG is isopropyl thiogalactosidase. So their galactoside. So IPTG is able to regulate the promoter of the LAGZ prime to induce the synthesis of the LAGZ prime, that is the beta galactosid, the alpha peptide of the beta galactosidase. So what we understand over here therefore is only when you wish to express LAGZ prime, you can express LAGZ prime by adding IPTG. So IPTG is the inducer. So here you can therefore very clearly say that when E. coli lacks the LAGZ prime, it does form the beta galactosidase, but the beta galactosidase is defective. When the E. coli takes up pUC8, pUC8 gives the LAGZ prime portion, that is the alpha peptide portion, and together the defective and the alpha portion form the complete beta galactosidase, which can be active. So therefore, let us look at how, using this strategy, pUC8 transformants and recombinants are observed. So this is the pUC8, where let us assume that we are using BAM-H1, which is one of the restriction endonucleases in the RE site in the multiple cloning site. So using BAM-H1, a new DNA or a gene of interest is inserted. With a gene of interest being inserted in the LAGZ prime gene, there is disruption of the LAGZ prime. So effectively, the LAGZ prime will become inactive. When this is transformed into E. coli, then after transformation of into E. coli and that E. coli being plated in a media that contains ampicillin, that contains XGAL, and that contains IPTG. So those E. coli that have taken up the normal pUC8 without the gene of interest will have its LAGZ prime active, because there is no disruption of the LAGZ prime gene. So there is no insertional inactivation. And so this LAGZ prime will be induced by APTG, and it will be able to, the product of the LAGZ prime will be able to break the XGAL into blue. So all colonies that are blue in color are transformants because they're growing in ampicillin containing media, but they are non-recombinants because the LAGZ prime is not inactive. However, those E. coli that have taken up the pUC8 with the gene of interest, in that the LAGZ prime is inactive because of the insert. So you see what is called as insertional inactivation. LAGZ prime will be inactive, and therefore you will not have this LAGZ prime product formed. And since the LAGZ prime product is not formed, XGAL will not be converted into the indigo dye, and so these colonies that are the recombinants will be white in color. So in one plate itself, you can distinguish between E. coli that are transformed but not recombinant, and E. coli that are not just transformed but also contain the recombinant. So both transformant and the recombinant is identified in a single step, which is one important prospect of using pUC8 when you compare it with PBr322. In PBr322, it was a two-step process where it has to be first grown in ampicillin and then it has to be replica plated on a plate containing tetracycline. And those bacteria, those colonies that would not be found in the tetracycline resistant, tetracycline containing media would be the ones that are recombinants. So this becomes an easy aspect with respect to pUC8, where in a single step itself, one is able to find out whether it is a transformant and also able to find out that it is a recombinant. So I repeat, those that remain as blue colonies are non-recombinants, while those that become white colonies are recombinants. So this process is what is called as blue-white screening, or it is also called as lag selection system. Now, pUC8 has been modified further to give rise to pUC18, pUC19, and so forth. So, the modification that has been done mainly in the multiple cloning sites by increasing the restriction sites in the polylinker. So, the polylinker has become longer, okay, with more choice of restriction endonucleases. And in this, what is also possible is that you could use two restriction endonucleases to create two different sticky ends. And so the choice or the use of restriction endonucleases for cloning increases with increased prospects of using different restriction endonucleases. Interestingly, what has been noted is that recombinant pUC8 can be clubbed with M13 MP8 to be able to kind of use the best of both worlds, that is a plasmid and a M13 phage. The two can be restricted with BAMH1 and EcoR1 in such a way. So you can see that this is one sticky end and this is the second sticky end. So one sticky end is created by EcoR1, the second sticky end is created by BAMH1, and you have the new DNA insert containing a sticky end of BAMH1 and a sticky end of EcoR1 easily getting incorporated in this recombinant M13 MP8. So therefore, such modifications are also possible, and the possibilities of cloning with using greater number of restriction endonucleases has been increased. So to get an overall summary of how to use pUC8, the pUC8, when is inserted with a foreign DNA, there are three possibilities. One is that the insert is within the lag Z. Okay, that is one possibility. So therefore, the lag Z over here will be disrupted. There will be insertional inactivation. In this case, the insert is not within the lag Z prime, but it is outside the lag Z. So here you will not find that the lag Z is inactivated. Or you can have self-ligation of the plasmid vector happening where no gene of interest is taken up and you have the lag Z prime again intact. So when these three possibilities are transformed into the mutant E. coli, okay, which is made competent, okay, to take up these plasmids, okay, you get three possibilities. One is with the gene of interest within the lag Z prime. So lag Z prime will not get formed, the product will not be formed. So the defective lag Z will remain as defective lag Z, and hence no beta galactosidase will be formed over here. Therefore, when this grows in a media containing XCal and IPTG, XCal will not be converted into a blue product and you will get white colonies. In this case, because the lag Z prime is not inactivated, okay, you will have the lag Z prime formed, which will complement the defective beta galactosidase of this E. coli, and you will have the blue product formed. So the colonies that will be formed will be blue colonies. So by these two, you can very well understand that only and only if the insert is within the lag Z prime, you will be able to distinguish between a recombinant. In this case, you will not know that it is a recombinant. And of course, the self-ligated vector will also form blue colonies because its lag Z prime is not inactivated. So let's make the conclusions. pUC8 series of plasmids have been constructed in the University of California. So P is for small plasmid, small p is for plasmid, and UC stands for University of California, with one of the main objectives being to enable selection of recombinants. pUC8 can take an insert of about 7 to 8 kb and can have a high copy number per cell. The ampicillin resistance is for transformant selection, while lag-C prime is for selection of recombinants. This enables selection of transformant as well as recombinant in a single step, which makes the cloning process much faster. Multiple cloning sites gives a choice of several restriction endonucleases, and in modified versions of pUC8, the multiple cloning site is bigger. Thus, pUC8 is based on lag set selection, effectively what we also call as blue-white screening, which makes the cloning vector a suitable vector. The clustering of restriction sites within the selectable marker is in alignment with insertional inactivation. Thank you.